between models, theories, and laws. So a model is something that may or may not be precise, but it's a way to understand the physics of something. So one of the models that they talk about in the textbook is the Bohr model of the atom, where you have the radius or the nucleus, and you have these orbitals, these circular orbitals around which the electrons move. So this is not scientifically accurate. If you've taken like an advanced chemistry class or you take quantum mechanics, you know that the orbitals are actually probability distributions and they're much more complicated than this. But it does tell us interesting things about the angular momentum. It does allow us to understand energy levels as being quantized. So it's something that is useful for the way we work, even though it doesn't show certain aspects of a physical theory. And then a theory is a testable explanation for patterns in nature, which is supported by scientific evidence. So you have the theory of evolution or the theory of gravity, which are both more complicated than laws, which are just theories that use concise language to describe a very generalized pattern. So you have the theory of relativity, which has a ton of different things going on in it. It has like length contraction, it has energy, it has time dilation, stuff like that. So that's going to be a theory because it's not very concise, but if you talk about Newton's second law, then all that is F equals ma. It describes a lot of stuff. It goes it's a very detailed accounting of the relationship between force and acceleration. So it gets to be called a law while the theory of relativity is theory. And then finally, we are going to go over some of the strategies that they have for solving problems. So this isn't really physics, it's just how you go about the math. So the first thing that you want to do when solving problems is examine the situation to determine which physical principles are involved. So basically, you're going to have to learn what types of equations are used for what types of situations. And then you do that before anything else so you know what equations to set up. Make a list of what is given or can be inferred from the problem as stated, which are identified as knowns. So if I tell you you're going 50 miles per hour, how long does it take you to go 20 miles? Then your knowns would be the 20 miles and the 50 miles, and you would relate the two, or 50 miles per hour. and you would relate the two together with a equation that you do in step 1, which is going to be the relationship between distance and velocity in time to solve for time. So identify exactly what needs to be determined in the problem, which is identify the unknowns. In that earlier example, that would be time, and determine which physical principles can help you solve the problem. So that's also going to be related to the first step, which is just examining the situation and figuring out what physical principles or what equations are going to be useful for you. And then that is basically it.